Hello and welcome to Aryabhata Ashram. I am Maheep and we are doing very important session called NYQ. That is your like-minded previous year question. जैसे previous years आते हैं वैसे questions. तो हमने पहले NYQs का सीरीज स्टार्ट किया और PYQs तो हमने सभी कुछ कवर किया है और हमारे PYQ से ही more than 95% questions आते हैं. तो हमने सोचा कि why not we should work relentlessly to get that 5% extra. So we have started this series called NYQ, and this is the question. This is the question of a complex analysis. So small r is between 0 and capital R. We have to evaluate this integral r plus z upon z into r minus z dz, where c is a circle of radius r. Okay, small r, and you have to reduce that 0 to 2 pi d theta upon r square minus 2r capital R cos theta plus r square is 2 pi upon r square minus small r square. Secondly, 0 to 2 pi sin theta r square minus 2r capital R cos theta plus r square is equal to 0. तो इस तरह के questions आपको already you have these kind of question in the examination. ठीक है, so you can see these questions already in examination. They have asked these sort of questions. So where they have asked the PYQ, they can also ask the certain questions from different sources, and we have collated and collected these questions. So let us do this question. Well, this is a very simple question because I can see here I have poles at z is equal to 0 and z is equal to r. Now I very well know that capital R is lying outside the radius of small r. Henceforth, that will be chucked up. So let us first try to do this integral and solve it. So I have this integral r plus z r minus z. Now what I will do, I will first of all write it in the standard format 2 times r minus z. I see here that what I have done, I have used partial fraction. That I will do in the rough work. I can very well write r plus z upon z into r minus z is equal to a upon z plus b r minus z. Now if I put a is equal to, now if you do r plus z is equal to a into r minus z plus bz. So if I put z is equal to capital R, so this is your 2r is equal to b. Therefore, b is equal to 2, and if I compare the coefficient of z, so I can say that 1 is equal to minus a plus b. That means 1 plus 2. So a is equal to 1, right? So I can very well find this partial fraction. That's not a big deal. So I have just done for those who could not understand this process, and this is very simple to begin with. Simple things, we often make mistakes. So simplicity is undoubtedly the ultimate sophistication. So you have forgotten a lot of things when you are not revising, when you are not doing it rigorously, when you are not doing continuously, and that cyclicity, that continuity, that flow is central to your success, and there lies the truth that you should embrace. Now, well, I see here that this is inside the unit circle, but radius is r. So this is very well inside this. But what about this? This is not inside because r, capital R is greater than this. Therefore, this is taken into account. This lies inside and this is outside. So I will write down this integral r plus z upon z r minus dz is equal to 2 pi I, because it lies in second r, because I have mod z is equal to r, small r. Henceforth, this is the case. Now I have very well found out the value of this contour integration. Now I need to deduce something more, that is 0 to 2 pi d theta r square minus 2 r capital R cos theta plus r square is equal to 2 pi upon capital R square minus small r square. Now you see here, what I will do, since my mod of z is equal to r, therefore z would be r e I theta. Now I can write this capital R plus r e I theta upon r e I theta r minus, correct. And what is dz? Dz is nothing but I r e I theta d theta. Now this is your I r e I theta d theta. Now this goes off, correct, and this is equal to 2 pi I. So I can write this integral from 0 to 2 pi capital R plus a small r e I theta d theta upon r minus theta. Now it definitely needs some sort of manipulation, and this is equal to 2 pi because I and I get cancelled. And here lies the crux of this question, because I need to rationalize it, and I very well know how can I get it r square. I very well know how I can get it cos and so on and so forth. So what I do, I multiply, and so I can write this as r minus r e to the power minus theta. Okay, in numerator and denominator, because I want certain things. And what do I want? That is something which you will be able to understand when I will show you what has to be deduced. So once I do this, this is r square minus 2r r cos theta plus r square. So इसमें क्या हो जाएगा, r square and small r square. So that will be taken into consideration. Okay. So very well you can write this 0 to 2 pi. Now this is r into r square. What about this fellow r into r? This is minus r square. Yes or no? E to the power I theta minus e to the power I theta, that is taken into consideration. Now what I do, I observe here one more pattern, that it is sine theta. So this is real part and imaginary part that you can take into consideration. So what I can do, I can take plus r, this is ei theta, right, and then minus of this is, and if I do 2i over here as well, so this is something which I can very well understand. Now this is r square minus minus plus. Now r capital R e to the power I theta plus e to the power minus I theta upon 2. Now what do you get? What do you get out of this? So this seems little cumbersome, difficult lag raha hoga, but it is not so. And I can write this 0 se 2 pi r square minus this plus 2i r. This is your sine theta upon capital R square minus 2r cos theta d theta, and this whole is equal to 2 pi. This whole is equal to 2 pi. So I can very well say that this is real part is equal to 2 pi. So I can write this r square minus a small r square minus plus r square minus 2r capital R cos theta d theta is equal to 2 pi. Yes or no? Because I am separating real and imaginary part. And from this I can also conclude or deduce that d theta upon r square plus r square minus 2r capital R cos theta is equal to 2 pi upon capital R square minus r square. This is what I can write. I can also equate the imaginary part. What is imaginary part? So I can write this imaginary part as 0 se 2 pi 2r capital R sine theta upon r square plus r square minus 2r r cos theta d theta is equal to 0. Yes, and this is what I am supposed to deduce. This is what I am supposed to reduce. You can see that I can write this sine theta upon r square minus 2r r cos theta plus r square. So we can say 0 to 2 pi sine theta r square plus capital R square minus 2r cos theta d theta is equal to 0, because r into r is not factored into, because ultimately it is multiplied by 0. That is what you should keep in mind. तो ये सवाल भले ही आपको initially difficult लगे, but if you practice, mathematics is all about practice. So the more you practice, are you getting, Kaushal? The more you practice, the better it is. So maths is about an exercise. You do the exercise, you do it every day, and that is going to change the whole course.